All right, so we have complex fractions today. Now, just because it says it's complex really doesn't make it more difficult. They do look pretty heinous when you first see them. They're not too bad. Just to, again, compare them to what they look like just with numbers. You might have had a complex fraction back in your younger years that looked like maybe 2 over 9, and then a big fraction bar, and then maybe 6 over 21 or something like that. And you had to simplify it. That ringing a bell at all? What did that big fraction bar there in the middle mean?
Division.
It did. It meant division. And so all you had to do to solve this, or to simplify this, I should say, was that we rewrote it as a division problem. And like we talked about on Monday, when you divide with fractions, what do you really do? I heard someone say it.
Multiply.
Multiply by the reciprocal. And now we simplify, right? And we simplify any numerator with any denominator, blah, 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 right? And you can use any order you want. Maybe this. And we end up with 7 over 9, right? Okay. That's going to be the same procedure we use with complex rational fractions as well. We're going to have a fraction that's the numerator. We're going to have a fraction that's the denominator. We are going to then rewrite it as a division problem, and then it's a problem we've seen before, right? We just simply rewrite it as a multiplication by flipping the second fraction, and then follow the rules that we did on Monday. Really, it's a buy one, get two free. You think you're just doing one problem, you're really going to be doing 3 problems. You're going to work out the numerator, you're going to work out the denominator, and then you're going to do a division problem, which is really incognito for a multiplication problem. So when it says complex fraction, it just means it's going to take you a while to get it done. So here's what they might look like. I'm going to leave that up there so you can see the similarity. Maybe we have x over x plus 2. That's our numerator. Our denominator is 1 over x plus 2 over x. Now, some of you really like those step-by-step instructions, so we'll provide those for you today. Step 1 is to express the numerator as a single fraction. Now, in this first example, is the numerator already a single fraction? It is, isn't it? X over x plus 2. It is a single fraction. So, number 1, step 1 is done for us at this point. Sometimes you might have to add to create that single fraction, or you would have to subtract to create that single fraction. But in this case, it's done for us. Now, step number 2, what do you think step number 2 is? Yeah, do the same thing but for the bottom. Express the denominator as a single fraction. Okay, in our example, is our denominator a single fraction? No, so we're going to have to do some work. Let's go ahead and do that. So it's an addition problem. What do we have to have? Common denominator. Can we factor the denominators? Can x plus 2 be factored? No, so that's a factor in itself. Can x be factored? No. Okay. Do they have anything in common? Is x a factor of x plus 2? No, it's part of an addition problem, isn't it? So it's not a factor. Factors are part of multiplication problems. So They do not share any factors at all. So off to the side, of course, we write what is going to be our least common denominator. They don't have anything in common. So I have to have x times x plus 2. Make sense? C. All right, so what is our first fraction missing? An x. So I multiply top and bottom by x. What's our second fraction missing? X plus 2. Top and bottom by x plus 2. So I'm just right below it, I'll write what would look like as a single fraction. I have the denominator as x times x plus 2. One times x is just 1x, right? Let's distribute the 2 times x plus 2. 2x plus 4. Combine some like terms. I have 1x plus 2x plus 4. 3x plus 4. So now I have expressed my denominator as a single fraction. So step 2 is done. My numerator is a single fraction, x over x plus 2. My denominator is a single fraction, 3x plus 4 over x times x plus 2. Step 3. Step 3 is what, do you think? Yep, let's rewrite it as a division problem. Now, as you know, whenever you write as a division problem, when you get better at these and you've practiced enough, you could go directly to rewriting as the multiplication of a reciprocal. But for now, go ahead and take the time to rewrite as a division problem, and then you know what to do from there, right? Let's see what this looks like now. We're going to write x over x plus 2 divided by 3x plus 4 over x times x plus 2. It's actually nice to rewrite it this way because it gives you an opportunity to go ahead and factor if you can. If there's ever a time to factor or a chance to factor, this would be the time to do that. If you have a numerator that could be factored, we don't this time. So how do we deal with division? Multiply by the reciprocal. So x over x plus 2 times x times x plus 2 over 3x plus 4. Anything simplify? X plus 2's. What about the x's? Can the x's simplify? No, why not? They're both in the numerator. Very good. So, final answer would be x squared over 3x plus 4. And your problem is done. And those are your 3 steps to dealing with complex fractions. So it's really not any more difficult than what you've done. It's putting really 3 problems into one problem, which means there are a lot of opportunities for you to possibly make a mistake. That's the downside of it, right? One little sign mistake, one multiplication error messes up the whole problem. So here's what I find students, they get really frustrated with these problems because they'll see what the answer is supposed to be and they don't get the answer. So immediately they go to, I don't know what I'm doing. I'm so confused. I don't understand anything. And that's not the case. The case is you missed a detail. As long as you're understanding those 3 concepts, you're going to write the numerator as a single fraction. Sometimes you have to do an addition problem or a subtraction problem to get there. Sometimes you have to write the denominator as a single fraction by adding or subtracting. Are you finding the least common denominator? Or, are you doing all those steps correctly? Then are you writing it as a division problem? Or, are you following those steps? If you make a detailed error, then okay, we'll find it, we'll fix it. But I don't want you to think that all of a sudden you don't understand the idea and you're just like, I don't understand anything. I'm so stupid. Please don't think that. I still make mistakes on problems like these. There's just a lot of opportunities for error because there's so many steps to them. All right, so we'll continue to practice these today, and in your homework that I give you tonight, you'll have 3 problems. I'm only going to give you 3 for homework, and I'm going to tell you what the answers are. So that way, if you don't get them right away, you can go back and find that detail that you missed. Does that make sense? Awesome. All right.